Guys, I show you a lot of Leibniz rule. I know. But I just realized that I think there's a more familiar version of Leibniz rule. You might think about it. You might say it. Some people say it. You know, some people say it's the fundamental theorem. Fundamental theorem of calculus. Some people say it's just derivative. But I really want to show you what is that. So if you remember in Leibniz rule, right? What do we interest in? We interest in taking derivative with respect to, say, with respect to x, okay? Of integral ax to bx f y x dy, okay? This is Leibniz rule. In baby Leibniz rule, let me write in red, baby Leibniz rule. We interest in, we also take derivatives with respect to x, but our function is no longer multivariable. Our function is just single variable. Okay, that's what we interest in. See, it's kind of more familiar, more simple, more simplified. Let me show you how to do this without actually calculate the integral. Okay, so I'm gonna show you how to do one without integral. Okay, now how you're gonna do this? Okay, so you're gonna you this is how you do it. You say assume fx is continuous. Okay, I don't know if it's worth for a continuous function, but this is a good place to start. Let's say you have f prime of x equal fx. Let me write. If let's say there's a function f such that, you understand? Let's say there's a function f that when you take the derivative of x, it will equal to f of x. Okay. So so what I'm gonna do is do this d over dx. Okay, is 1, right? We want to calculate 1, right? What is 1 equal to? First, you write out the original meaning, the original version of the problem give you, right? And then you plug in what you have. So what your assumption, what's your setup? I'm gonna plug f prime x into that. So t over dx of scroll f bx ax of what? F prime x dx, right? Okay, so do you agree with me? The inside will equal to f of bx minus f ax. Okay, this is just what you call it? This is just chain rule. Okay, no, this is just like you remember. Yeah, this is just like this. Yeah, does this sound familiar? Yeah, that is exactly. I just replace small f with big F. It's just a character, a notation. You don't have to worry in this case. Although I know f prime of x is equal to fx, but this is just I'm replacing the character, so you don't have to worry about any of that. Okay, so let's proceed. What is the derivative of b of x with respect to x? Okay, chain rule, guy. Chain rule. Okay, so it would be f prime, right, of bx times b prime x. Okay, then minus f prime a of x times a of x. What does it mean? It means that f prime b of x is you take f prime first with respect to x. Okay, and then you plug in bx. This is what this means, and then you time the derivative of bx with respect to x. So that's what b prime x means. Okay, Now, what is f prime of bx? So f prime of x is fx, right? So do you agree with me that f prime of whatever it is inside equal to f of that inside, okay? Or you can say f prime something equal f that thing. Okay? Does it make sense? So f prime of what? F prime of a of x equal to f of x. Okay, so this is f of b of x times b prime of x minus f a of x times a prime of x. Okay, ladies and gentlemen, this is our formula to calculate 1. Okay, so let's actually do one example. Okay, I'm gonna do it 2 ways, and then you guys can check where I do it right or wrong. So I want to calculate d over dx integral of from x to the power 4 to x to the power 5 x dx. Okay, I want to calculate that. But first, let me do the traditional way. The traditional way is you evaluate the integral first. So equal d over dx of what? Of, integral of x dx is x squared over 2. Right? So it would become d over dx of, you replace x, okay? Replace x with x to the power 5. So x to the power 5 square over 2. Okay, replace x with x to the 5, x with x to the power 4 minus x to the power 4 squared to the power 2 equal to d over dx of, this x to the power 10 over 2 minus x to the power 8 over 2 equal to 10x 9 over 2, right? Okay, yeah, because remember, derivative of x to the power n equal to n x n minus 1, okay? Minus derivative of x to the power 8 is 8x 7 over 2. Okay, this is our answer. Okay, let's do the new way. Okay, let's do the new way and see if the answer we got the same thing. So d of dx over x, what's that? x4, x5, x dx. Okay, what do we equal to? In this case, fx is x. Okay, in this case, fx is x. So it will become, yeah, let me write the notation first if you guys not familiar with it. Right, remember this? That's what our formula, right? So in this case, what is f of bx? F of bx is f of x to the power 5, which is x to the power 5, okay? Okay, b prime of x. What is b prime of x? Bx is 5, right? 5 x to the power 5 and take the derivative is 5x4, right? Because this is, okay. Similarly, f of a of x is x to the power 4. Let me write gradually for y'all. I'm not gonna save my mouth. So this is f x to the power 5 times x5 prime minus f4 times x4 prime, right? F to the power x to the 5 is x to the power 5 because fx equal x. So f something equal that thing. So times 5x4 minus 4 times 4x3. Okay, become 10x to the power 9. Oh, sorry. Become 5x to the power 9 minus 4x to the power of 7. Is these two results similar? It is similar. Yeah, I forget to simplify this. I'm sorry, guys. This is 5x9 minus 4x7. Okay, is it similar? It is similar. But I just proved one equation though. You guys can prove, you can test this for yourself, have fun. It's really cool, there's, you guys can do any way you want, but the new way, or let me call it baby left this way. This way right here is that you do it without have to do the integral. So yeah, this is how you actually do it. Just make sure you double check. Make sure you work it, weigh it until you understand it completely. So thank you so much for watching my video, and I hope you have an amazing day or night, whatever timeline y'all in. Take care and stay safe.